In this video, we're going to learn about L'Hopital's rule, when to use it and how to use it. We're going to look at two cases. So for case one, it says for differentiable functions f of x and g of x, if we have the limit as x approaches c of a quotient of functions f of x divided by g of x, where both the limit as x approaches c of f of x equals 0 and the limit as x approaches c of g of x equals 0, then we can do a really cool thing. That's L'Hopital's rule. The limit that we're trying to solve for is going to be equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x. But in order to use this, these two conditions must be met. So let's make sure that is true of this first problem before using L'Hopital's rule. So the first thing we check is, does the limit as x approaches 2 of the numerator 3x squared minus 7x plus 2, let's see what this will equal. By direct substitution, by plugging in 2 for x, 3 times 4 minus 7 times 2 plus 2, that gives us 0. Now let's check the denominator. The limit as x approaches 2 of the denominator, x minus 2. By simple direct substitution, you can see that that is also 0. Therefore, our conditions in order to use L'Hopital's rule are met. So then I like to write over here, therefore, L'Hopital's rule applies. So here's the fun part. We apply it. Let me scroll down here to give us some more room. So this is going to equal, so that limit then will equal the limit as x approaches c of the derivatives of the numerator and denominator. The derivative of 3x squared minus 7x plus 2 is 6x minus 7, and the derivative of x minus 2 is 1. Now you can use direct substitution and plug in 2. Therefore, our answer will be 6 times 2 minus 7, or 5. And that's how to use L'Hopital's rule. I'm going to bring in a special guest to remind us of something. Molly, what do you have to say? This is Molly, and she is saying, don't forget to state the conditions, right? In order to use L'Hopital's rule, these conditions must be met. So you do have to state this part, and you do have to state this part. You can't just jump right into L'Hopital's rule. Hey, Molly, thanks for that reminder. By the way, if you're finding this video useful and you like to see Molly some more, please give this video a thumbs up and subscribe. All right, thanks for your help, Molly. I think we need to do case 2 now. Let's look on to case 2. And Molly's going to be going away for a little bit. All right, case 2. For differentiable functions f of x and g of x, if we have the limit as x approaches c of the same quotient of functions, where now both the limit as x approaches c of the numerator goes to either positive or negative infinity, and the limit as x approaches c of the denominator also goes to positive infinity, then you can use L'Hopital's rule. So either 0 divided by 0 or either positive or negative infinity divided by positive or negative infinity. So let's make sure those conditions are met. The limit as x approaches infinity of e to the 2x would equal, by thinking about plugging in infinity, it would be e to the power of 2 times infinity, which is an enormous number. E to the infinity is infinity. Now for the denominator, the limit as x approaches infinity of 5x squared plus 1, that would be 5 times infinity squared plus another 1, again, a huge number. As you can see, the conditions in order to use case 2 are met. Therefore, L'Hopital's rule applies. And let's go ahead and apply it. Here's the fun part. So this limit would equal the limit as x approaches infinity, and I can apply L'Hopital's rule by taking the derivatives of the numerator and denominator. The derivative of e to the 2x is e to the 2x times 2. Don't forget that chain rule, divided by 10x. Now I think about plugging in infinity again. So this would be e to the 2 times infinity times 2, again infinity, divided by 10 times infinity, infinity again. You know what? This is so fun that we get to do L'Hopital's rule again, another round. Let's do it. So the limit as x approaches infinity of e to the 2x times 2. In my head, I'm thinking, okay, that would be e to an enormous number times 2. I would get infinity. And then the limit as x approaches infinity of 10x. I'm thinking in my head, 10 times infinity, again, an enormous number. So therefore, L'Hopital's rule applies again. All right, let's go for it. So this would equal the limit as x approaches infinity of, so I'm going to rewrite the original as 2 times e to the 2x. So the derivative of that would be 2 times e to the 2x times 2 divided by 10. Now, L'Hopital's rule wouldn't apply again because if you think about it, the denominator is just 10. So there's no possible way I can come up with infinity over infinity. So now I just use direct substitution by thinking about plugging in infinity. 2 times e to the infinity times 2 would be infinity divided by 10, which is none other than infinity. And there's L'Hopital's rule, and it's 2 cases. I hope you found this video useful. If you did, give it a thumbs up and subscribe. Thank you so much for watching.